All right, let's talk about another kind of translation altogether, and that is a reflection. So we're not moving things left or right or up or down anymore. We are going to reflect them over some axis. All right, here is a parabola, and this is the function for the parabola, and it's shown in this graph. We are going to consider the function g of x, which equals negative f of x. All right, if I'm going to have negative f of x, all right, negative f of x is just going to be f of x, whatever that is, and I'm going to make it negative. So it's negative x squared minus 6x plus 5. Okay, and if I distribute that negative, I'm going to get this new function. This function g of x, which is equal to negative x, which is equal to negative f of x, which is negative x squared plus 6x minus 5. Okay, and so now we would like to graph that function. All right, if you use Desmos, if you use a graphing calculator, whatever you do, you would get that the new vertex is right here. All right, from Algebra 1, you might remember that the vertex is negative b over 2a. So in this problem, b is 6, so negative 6 over 2 times negative 1. If you don't remember that, that's okay, we'll get there. But that means that the vertex would, the x value of the vertex would be at 6 divided by 2, which is at 3. So it's still at 3, and if you plug 3 in, g of 3 would be 5. Trust me. You can go ahead and use a graphing device for this, and you would get your zeros to be here and here, and you would get these points to be over 1, 2, right here and here. I had to count that out. All right. So if I graph this on Desmos or on a graphing calculator, I would get that this parabola has been flipped upside down. All right. And what we say about that is we say that it has been reflected in the x-axis. Okay, the shape stays the same, everything stays the same, it's just mirrored over this line y equals 0. Okay, now let's consider the function h of x equals f of negative x. If I find h, well, let's do a different color. Let's do h of x equals f of negative x, which means every x value is going to now be negative x, which would be negative x squared minus 6 times negative x plus 5. So if I simplify that out, negative x squared is just x squared. Now this is plus 6x plus 5. All right. When I'm graphing a parabola, it helps to factor it. So I'm going to say that this factors into x plus 5, x plus 1. So the zeros of my new parabola are negative 1 and negative 5. 1, 2, 3, 4, 5. And if this looks crazy to you, you feel free and use a graphing calculator to do this. All right. My y-intercept is up here at positive 5. I can mirror that over here. And then my vertex will be down here. So I have a new parabola right there. All right. So if I have the negative on the inside, then what's happened is I've taken this black original function, which is f of x, and I have mirrored it over now the y-axis, or the line x equals 0. And we say that that is reflected in the y-axis. I'm squishing that in there. All right. Now, if it's reflected in the y-axis, this makes sense. Anything that happens on the inside happens to the x's. So I'm moving the x's over the y-axis. Anything that happens on the outside, like this negative sign here, when I formed g of x, I formed it because the negative was on the outside. Anything on the outside affects the y's. So in this red function, I have moved all the y's to reflect it over the x-axis. Okay. So here we are one more time. Negative f of x is a reflection of f of x in the x-axis. The negative on the outside moves the y's, and it moves them over the x-axis. The function f of negative x is a reflection of f of x in the y-axis. So anything on the inside moves the x's. It's going to reflect them over the y-axis. All right. So let's look at an equation for this g of x after reflection in the x and y axis. Well, so I want to do two reflections. I'm going to call my new equation h of x. And h of x is going to equal negative g of negative x. All right, two reflections, one on the inside, one on the outside. So what does that look like? Well, I'm going to have a negative entire function. I'm going to have 5 times negative x minus 7. So I have an input of negative x, and then I've also made the entire function negative by putting that negative sign on the outside. So if I clean this up, I get negative 5x minus 7, which is 5x plus 7. All right. So those are my equations. That's my equation after I've reflected it, both the x-axis and the y-axis. I'm going to call that h of x. All right, if I have a parabola, quadratic, that has this equation, if I want to represent its equation in the reflection in the x-axis, reflecting over the x is reflecting in the vertical direction. So that means my negative sign is going to go on the outside. Anything vertical happens outside of f of x, which means that I'm going to have a negative 2x squared minus 3x plus 8. And if I clean that up, I get negative 2x squared plus 3x minus 8. All right, so that final equation is option number 2. And if I have this quadratic g of x and I want to reflect it in the y-axis, reflecting it over the y means I'm going to move in the x direction. So I want to affect the x's, so I'm going to put my negative sign inside, affecting the input. G of negative x means that all my inputs are going to change to negative x's. So I get negative x squared minus 7 times negative x plus 2. Negative x squared is still x squared, so this stays the same. But negative times a negative here is a positive 7x plus 2. So 4x squared plus 7x plus 2 is option 3. That's a reflection in the y-axis.